Afternoon. Today we'll be talking about atoms. I'll elaborate later. I'll play a video at the moment, a very short video to show you what an atom is. And then after that, I'll do a very short PowerPoint presentation just to guide you around the topic that we're having today. Okay, cool. Let's watch the video.
Or they're not possible to see with the naked eye. They're only possible barely to make out with the most powerful microscopes. Everything that exists in our universe is made up of atoms, including you, I, and the device you're watching this on. In fact, there are about 7 billion atoms in your body alone, which is 7 times 10 to the 27 atoms. But what is an atom? In this video, we are going to look at what atoms are made of, and the mass and size of atoms, and the arrangement of electrons in an atom. Atoms may be tiny particles themselves, but they are made of even smaller particles called subatomic particles. Atoms consist of a central nucleus that contains protons and neutrons. Protons are positively charged, and neutrons have no charge. This makes the nucleus overall positively charged. Much like how the Sun has planets orbiting it, the nucleus has electrons orbiting. Electrons have a negative charge. Because electrons are negatively charged and their nucleus is positively charged, they are electrostatically attracted to each other, like how gravity ensures attraction between planets and the Sun. So that's the general structure of an atom. What about its mass and size? Protons and neutrons have the same mass, but electrons are so small they weigh almost nothing in comparison to protons and neutrons. In fact, they are around 2,000 times lighter. As a result, the mass of an electron is concentrated at its nucleus. So that's the mass of an atom. Let's talk about its size. One way to describe the size of an atom is its radius. The radius of an atom is the distance from its center, where its nucleus is, to the outermost shell of electrons. The radius of an atom is typically 10 to the power -10 meters, which is very small. So the majority of the mass of an atom is contained in its nucleus. But in terms of size, the nucleus is much smaller than the atom as a whole. In fact, electrons can orbit really far away from the nucleus. If the atom was the size of a sports arena, the nucleus could be the size of a pea in the middle. Let's finish off by looking at the electrons in a little more detail. Negatively charged electrons orbit around the positive nucleus in specific orbits or shells. Different atoms have different numbers of shells, or orbitals. Each shell is of a specific energy level, meaning an electron must possess a certain amount of energy to reside in a certain shell. Electrons in shells closest to the nucleus have the least energy, and electrons in the outermost shell have the highest energy levels. In other words, electrons orbit the nucleus similar to how planets orbit the Sun. However, electrons can only orbit at specific distances and with specific energies. We will look at the differences in structure of atoms of different elements and the periodic table in this video. So there we have the structure of an atom. Atoms have a positively charged nucleus made up of positively charged protons and neutrally charged neutrons, which is orbited by negatively charged electrons. The majority of the mass of an atom is found in the nucleus, and the typical size of atoms is 10 to the power -10 meters. To learn about how we discovered the existence of atoms and the structure of atoms, watch this video.
Okay, looks like she's oh, okay, good. Now. So now, that was a video on atoms. So now I'm going to go through now what is an atom. So an atom is basically just a building of matter. Now, which means when there's two or more atoms, those build something. Sometimes they build a molecule or whatever that is called a matter. Now, atoms have several of same elements. They have identical identities, which means the atoms of a hydrogen are exactly the same with other atoms of hydrogens, right? Now, atoms of different elements are different in mass or in size, which means that an atom of a hydrogen and an atom of a carbon, they differ in mass, or the other one is heavier than the other one. There's gases, there's solids, there's liquids, there's different types of, of matter. Now, looking at the next slide. Now, when I say that different masses, this is what I mean. For example, when you look at here, oxygen and hydrogen, yeah, they have different masses because they're of different elements. They're not the same elements, so of course they've got different masses, which is the same as carbon and oxygen. They also have different masses. But even though they have different masses, they can from there react together to form something, or to form one thing, which is a molecule. So which means different elements are therefore they form a molecule when they react, which is one molecule. So I wanted to show you an example as to what I mean by that. I hope it's on the next slide. I'm not even sure. Anyway, okay, cool. So this is the question, the basic question that I wanted to ask myself, so that maybe you understand better the logic behind this, or as to why atoms behave the way that they do. So what I did was, I wanted to explain to you chemically as to why things happen the way they do, or why atoms end up reacting with each other to form a molecule. Most of the times these atoms, they react because they're simply looking for electrons to fill. They have orbit circles, so they're looking to fill that orbit circle or whatever that's missing, so they normally react together to form a molecule. So on a logical level, they create gases, very important gases for us. For instance, when oxygen reacts with hydrogen, which is HO2, brings you about your rain and your water, and carbon dioxide, which is brought about carbon and oxygen, which is very important. Otherwise, they wouldn't be living. If you know that you breathe out carbon dioxide and you breathe in oxygen, so which means if there was no carbon dioxide, you wouldn't be able to even breathe. So even though atoms are very small, they're unbreakable, but they still matter on a long run. So let's look at the next slide. Now, the question is, because we can't see this, how do these things happen? Now, they come about a topic what we call subatomic atomic particles. Now, those are the smaller, even smaller masses. Now, what are those? When you talk about that, you talk about protons, neutrons, and electrons. Now, protons and neutrons, they both exist within the nucleus of an atom, and they're positively charged. Why are they positively charged? It's simply because protons have a positive charge while neutrons have no charge, and therefore the nucleus becomes positive. Electrons are negative and they're orbiting around the nucleus. These are they have very low mass. They almost weigh nothing, while the nucleus weighs a lot of weight, actually. Differ from one and the next. So I made an example of how these atoms borrow. This is what we used to call it in high school, or back when I was still studying. My teacher used to say they borrowing the electrons. Now when you have oxygen and you have hydrogen, to get water, this oxygen has about 6 on the outer layer. It needs 2 more to complete that circle. Hydrogen has 1, each has 1. So it borrows those electrons, they come, fill it here, and then it becomes water, which is the same as carbon and oxygen to produce carbon dioxide. This is the part where I wanted to ask if anyone has a question on what I said, or wants to say anything at all. Any questions so far? Are we good?
Yes.
We're still okay?
Yes, sir.
Okay, let me see. So I wanted to ask, I'm just going to ask 2 questions. I want to choose which ones.
But I also do have a question.
Mm-hmm.
How do you actually measure atoms?
Now, great. So atoms, you don't measure atoms. So how you tell as to how much or how much it weighs?
Yeah.
What you do is you. Okay, let's go back to this slide. So normally they say you measure it by radius. So from the nucleus, exactly, or the middle part of an atom to the first or the first outer layer of the nucleus. So whatever that gives you there, that normally is what they calculate as a metaphor.
Yeah.
Right? Because they're very small and you can't really see it unless you're using a microscope. So that's how it gets there. Okay.
That's understandable.
Cool. Thank you, sir. So now I'm just going to ask which ones. I'm going to ask about these questions. This one question, like, are all atoms the same? Now, this is the question I'm asking from you. Are all atoms the same or are they different?
They're different.
They're different. So they're different. Different. Okay, and there's my question. Okay. So what I wanted to do was, at the end of the class, I wanted to give you guys an assignment or to work in pairs and develop a model, a 3D model of an atom. Now I made an example, or I built my own Smolanyana model. So this is a what atom is this? No one has an answer. What atom is this? I just made an example, but it's got 6 electrons on the outside and 2 in the inside. So it's got 8 electrons. Okay, cool. Let me show you something now. Before let me show you something. I think I missed something. So now this, I missed a project to explain how you come about these electrons, right? Now from the periodic table, these are elements, they're all elements, right?
Yeah.
That is an atom of an oxygen, right? So because it's got 8 electrons on the circles or the shells or whatever you call it, so that 8 always we call an atomic number. So the 8 electrons you get from there is an atomic number from the periodic table, which is the same as the 1 hydrogen and the 8 oxygen, which brings about water when they react. So when you're building an atom, the first circle takes 2 electrons, the second one takes 8, the third one takes 16, and so forth. So you need to understand, when I'm asking now, like, what type of atom is that? When it's got 8, that's oxygen. When it's 16 is sulfur. So what else did I want to explain? Oh, I wanted to explain the matter of the colors of these. So what this means basically is that there's different elements in the periodic table, obviously. So some are metal, some are non-metal, some react with each other, some don't react with each other. There's basic things that you can't really put what you call, what example can I make? Well, oil and water don't react. They just repel each other because the masses of them that are not the same, therefore they don't react. So that's what this means. So that is an element or an atom of the oxygen, right? Does anyone have a question, or is still okay? Hello? All is well. All is well. I think I shall send a sentence. I need another 15 minutes. But anyway, this is what I will do. One thing on the other side here and try to draw it from the periodic table. Hopefully that's going to get some time. Cool. Right. So let's say, for example, we want to draw, not build like a 3D, like draw just a flat 1D type of thing, an atom of nitrogen, for example, right? I don't think we spoke of nitrogen, we spoke of hydrogen, oxygen, and carbon. So, of nitrogen. Now, drawing that, I don't know if my computer is going to allow me to draw, but let me see if I can draw it. There's a program called Paint, so I normally use it, but it's very skewed, so I'll try and use that. Because I don't have a blackboard, so forgive me for that. I'll try and draw. If I had a blackboard and a chalk, I'd probably draw it more nicer and accurate. Great. So, yeah. What the hell? Where is this now? Oh, I was here. I said we're doing what, Kanan? Nitrogen. So let's do that. I'm gonna try and use a pencil and select size. Make it a bit bigger. Okay, so I'm gonna try and draw a circle. If my circle is not very circlish, don't mind my circle. Cool. So no, that is bad. That is very bad. Okay, let me start with the center, with the nucleus. We call that a nucleus, ne?
Yes,
Don't mind my drawing. Get it, but it's not in the middle. But anyway, it looks like one. Don't move. It looks like I can't draw a circle. I'm struggling to draw a circle. Can I use a shape? I think I can use a shape. I can use a shape. This. Perfect. So now I can erase that. One. So we can use another shape. Then, okay, let's make another one. Last one. Okay, that is not it. Okay, cool. I said the atomic number of nitrogen is what is it? Is it 7? I think it's 7. Yeah, it is 7. Anyway. Is it 6? 6? Okay, let's have a look. Oh, it is 7. It's 7. 7 is 7 of them there. Okay. So now I said the first cycle takes how many electrons? 2. The first cycle takes 2, the second one takes 8.
16.
And so forth, yeah. So let's see here. Use a star here. So now my color machine is not running. So that's the first one there. The second one there. Move that one. Hey. Hey. Okay. So now which means we're left with how many? 5. So the next cycle will generally take those 5 electrons, which you can put there, and put elsewhere. Now you can see it. Yeah, and put one there. So you can see that there's 1, 2, 3, 4, 5. There's 1, 2. So the first cycle took the first 2, the other one took the remaining one. Now if you want when it happens, in fact, because there's still one electron missing here, so this will be very easy for nitrogen to react with hydrogen, because one hydrogen needs. In fact, it would not. Would it be easy? Because it's got 1 and that's got this one has got 5, so it would be easier to react with something that's got 3 on the outer shell. Let me see. So, like carbon, I do react with carbon. So, well, in fact, it does. There's something that's called carbon nitrate. I think it's what is an acid that's developed from the reaction of carbon and nitrogen. So it's carbon nitrate. I think it's used in the hospital or something like that. But anyway, that is an example. So anyway, you said you don't have questions, so I'll end it for here for today. So thank you very much. X, you can't pause it. There's no dictator, so I'm asserting an umshire. What was problem?
Not today. You pause it. Go see it. Go see it. Then I pause. So Jesus.
I was going to TV.
I lecture Jadi.
Emotional. Yazama enye into ndidinwe nokudinwa mfana.
Yalifaka izinyo lakhe lo mhlekazi.
Ngokusithela nje akayi-1 seningcolise kangaka. Ubuye.
Hayi. Yo.